Look at the top half of Africa, and you will find roughly 3.6 million square miles of sand, rock, and relentless sun. The Sahara is the largest hot desert on Earth, a hyper-arid expanse roughly the size of the entire United States. But imagine if you woke up tomorrow and that sweeping orange wasteland had vanished, replaced overnight by a deep, oceanic emerald rainforest. This scenario is a matter of historical record. Just 11,000 years ago, during an era known as the African Humid Period, the Sahara was a sprawling paradise of rolling grasslands, dense forests, and enormous river systems. Prehistoric humans navigated this landscape in canoes, fishing and hunting alongside hippos, giraffes, and ancient buffalo, a lost world recorded directly in the stone of the region's mountains. This diagram shows exactly how it happened. Earth naturally wobbles on its axis, and every 23,000 years, it shifts its tilt just enough to pull the heavy storm clouds of the West African monsoons significantly further north. That moisture once pumped trillions of gallons of water into a depression in the earth to form Lake Mega Chad, an ancient inland sea larger than all the North American Great Lakes combined. The land itself is physically capable of housing a global super ecosystem. If those monsoons returned today, the global impact would be immediate. Billions of new trees would act as a colossal carbon sink, vacuuming atmospheric CO2 and driving global temperatures down. This animation illustrates the albedo effect, which measures how much sunlight the Earth reflects back into space. Right now, dark desert sand absorbs massive amounts of heat. Cover that sand with a highly reflective canopy of moisture and thick white clouds, and the entire northern half of Africa physically cools down. This localized cooling changes how heat moves through the atmosphere, shifting the path of global jet streams. The air masses that stall over Europe, creating record heat waves, are pushed aside by cool, moist air rolling off the new African forest. Even better, the dry, blistering air masses that normally blow off the Sahara, the exact systems that fuel major Atlantic hurricanes, would cease to exist. As a result, tropical storm formation would entirely plummet. On paper, humanity solves the climate crisis. We engineer a green utopia. But nature operates on a strict system of balances, and a sudden geographic alteration in one hemisphere can create a crisis in another. To understand the price of this utopia, you must look across the Atlantic to the Amazon rainforest, the most biologically vibrant environment on Earth. The Amazon is actually a botanical paradox. Despite its dense, towering canopy, it has some of the most nutrient-poor soil on the planet. The constant, heavy rainfall that sustains the trees simultaneously washes all the vital minerals out of the dirt. Because the soil is essentially sterile, the basin cannot sustain its own growth. It relies completely on an external life support system flying in from thousands of miles away. The world's greatest jungle is not an independent loop. It's a fragile dependent that requires a massive, constant infusion of outside fertilizer just to survive. This map identifies the exact source of that fertilizer. Here, deep in the nation of Chad, sits the Baudelaire Depression, a massive, dried-up, ancient lakebed. Every single year, fierce desert winds whip across this flat expanse, lifting over 180 million tons of fine mineral dust high into the atmosphere. That colossal dust cloud travels thousands of miles west, blowing off the African coast, crossing the Atlantic, and settling directly over the South American basin. This Saharan dust contains high concentrations of phosphorus, the specific vital mineral that the Amazon lacks. As it falls over the rainforest, it replenishes exactly what the daily rains wash away. This creates a fatal mechanical link between the two continents. If you cover the Sahara in grass and roots, you trap the dust in the ground, and if you stop the dust, you instantly shut off the Amazon's only source of food. Within decades of the Sahara turning green, the starvation of the Amazon begins. The vibrant canopy turns brittle and yellow as ancient trees die back. The wet jungle collapses into a dry, highly flammable savanna. Millions of plant and animal species lose their habitat, triggering a sudden mass extinction event across South America. As the Amazon rots and burns, it releases billions of tons of stored carbon back into the atmosphere. Every ounce of CO2 captured by the new African rainforest is negated by the destruction of the South American one. Artificially forcing a climate paradise in Africa directly triggers a catastrophic dieback in South America. This model demonstrates how Earth operates on a strict zero-sum ecological balance sheet. You cannot simply add a massive variable to one side without an equal subtraction from the other. It reveals a brilliant, brutal paradox. The world's most vibrant, life-filled rainforest can only exist today because the world's harshest, most desolate wasteland is there to feed it. Our planet is not a collection of separate modular continents. It is a single, highly sensitive, interconnected organism. Any attempt to overhaul the geography of one continent risks fundamentally breaking the mechanical links that sustain another. Turn the desert green, and you change the color of the world forever.